science all day. Hi guys, welcome back to my channel. Genetic mapping is what we're going to be discussing today. So, what is a gene? A gene is a unit of heredity passed down from parent to offspring. A combination of genes is what makes us who we are today. You get some genes from your mom and some genes from your dad. For example, the sex chromosome, which determines the biological sex of an individual, can either be XY or XX. Depending on what genes are on those chromosomes, it can affect the outcome of your sex. That being whether you are biologically male or female. Genetic mapping is used to determine the location of a gene on a chromosome. We use the 3-point cross to determine the recombination frequency of a specific gene. The recombination frequency refers to the comparing of recombinants to the parents. Depending on these frequencies, we can determine the location based off how far the genes are from one another. In this 3-point cross problem, we are given a normal parent and a wild-type parent. When we cross the two parents, we get our test cross. If given the test progeny and nothing else, we can determine the parents by the highest values. For example, VGB-PR and VG+B+PR+ are both high values, making them parents. The lower values are known as recombinants. We can see a double crossover in the lowest values of 13 and 9. A double crossover occurs when two fragments of a chromosome are exchanged in two places. Let's try a few problems. We are given our test cross progeny. So, what is the recombination rate of VGB? To start off, we need to identify the parents. In this case, VGB-PR and VG+B+PR+ have the highest values, therefore are the parents. Let's start with VG+B+PR. Since we are only looking at the relationship between VG and B, we are only looking at those genes. Since VG plus B values do not correspond to the parents, it is a recombinant. Therefore, we can write the number 252 as a part of our recombination rate. Let's go to the next one. VG plus B PR plus. VG plus B does not correspond with our parents, so we can write 131 as a part of our recombination rate. Next, we have VGB plus PR, which does not correspond with our parent, so we can write 118 as a part of our recombination rate. Next is VGB PR plus. VGB does match with our first parent value, therefore we do not include it in our recombination rate. Next is VG plus B plus PR. B plus does match with our first parent value, therefore we do not include it in our recombination rate. To solve for the recombination rate, we add the non-corresponding values and divide it by the total values and multiply by 100 to give us a percentage. So we'll take 252 plus 131 plus 118 divided by 4,197 times 100 to give us 17.7 map units. And we'll do the same for the following problems. If you want to take a moment, pause the video and figure out the recombination values of VG and PR along with B and PR. For VG-PR, we found a recombination rate of 12.3 map units. For B-PR, we found a recombination rate of 6.4 map units. We can analyze these values on a genetic map. We can see how far the genes are from one another on a chromosome by determining the recombination frequencies and creating a genetic map. As we can see, 17.7 is very close to 18.7. This is a great method for determining how close genes are to one another. Quiz time! Take some time to pause the video and work on the following problems. Question 1. What is the SP-PX recombination rate? You should have a value of 0.2%. As for the recombination rate of SP-CN, you should have 14.8 or 15%. The parents in this test cross progeny are PX plus, SP plus, and CN, along with PX, SN, and CN plus. The double crossovers are found in PX plus, SP, CN plus, and also PX, SP plus, and CN. If you enjoyed this video, make sure to leave a like and subscribe for more videos like this.
Baby, you are not to blame at all when I'm the one that pushed you away. Maybe if you knew I